Hey guys, welcome back to our segment routing traffic engineering series. In the last episode, we kind of talked about the segment routing ODN, which is the on-demand next hop feature. And we kind of mentioned that ODN is simply called as ODN templates because these are not just the policies. Because if you recall, for a policy, there were the three things that we needed. There is a source, there is a destination, and there is a color. But during the ODN, we learned that there is no such thing as the endpoint into the ODN during the configuration. During the configuration of ODN, there are only few things that we went ahead and configured. One of the things was like a color, and then we said, okay, hey, how do we want to compute the path to our endpoint? But there was no an actual endpoint, and we said the endpoint kind of really comes, which is on demand based on certain conditions. And we have talked about the BGP. So for the ODN, it is mostly used with the combination of BGP. And sometime if you look at some of Cisco's official documentation, it is also called as BGP automated steering, or simply known as BGP-LS. So what I'm saying, this is also called sometimes some document you will find as written as BGP-LS. Do not confuse with the AS as the BGP-LS number. Here the AS really stands for automated steering. So that's what we are talking. So in this case, we will be configuring BGP. And I kind of gave you an example yesterday. Why would you go ahead and use the ODN? And we had talked about one of the very common problem when you work with like a VPN services. Now it could be a layer 2 VPN service or layer 3 VPN service. So now once you have a VPN service, now we can go ahead and start making use of the BGP's extended community attributes. And using those community attributes, we can go ahead and simply start coloring the routes that we are sending. That means once the route is received on a head end, the head end will see that route with a certain color. And if we have a corresponding ODN template matching that color value, it can go ahead and spawn a SRTE policy using that ODN template, as well as looking the route it's receiving from that particular router. And that particular router will become your endpoint. And once the coloring is done, now as I said, the service policy will come up. And once the policy is up, we can have, the SRTE simply is working. So for this particular lab, again, I went ahead and I'm using one of our old topology that we have seen earlier. So in this topology, we have multiple routers. So we will be working with router 1 and 10 here. So right now the router 1 and 10 has a BGP session with these core routers. So in this case, our core routers are 4, 5, 6, and 7. So the router 1 has a BGP session with router 4 and 5. Router 10 has a BGP session with router 6 and 7. And let me go ahead and quickly show it to you. Let me log into router 1. And if I go ahead and quickly show the BGP session, so if I do show BGP sessions, you would see that the router 1 has a BGP session with router 4 and router 5. In our case, these are the router 4 and 5. Similarly, if we log into router 10, let me go ahead and log into our router 10 here. And let's take a look. Show BGP sessions. And now, in this case, you can see the router 10 has a BGP session with 6 and 7 in this particular case. Now, once the BGP session is established, I gave you an example, okay, we can go ahead and make use of the ODN when we have any kind of a VPN services. So on both of his router, I went ahead and configured a VRF as well as a VPN. So let me go ahead and show you that. So I'm doing show running configuration for VRF. So I have created a couple of the VRFs in this particular case. So I have a VRF by name VPN1. I have VRF by name CBlue here. And within this VRF, we have an address family where we are importing certain route target, we are exporting certain route targets. Similarly, for other VRF, we are exporting a different RT and different RT value where we are using for both import and export. And if you see, we have done the same configuration on our router 2. So if I go ahead and do the same thing, so now you can see that we also have a VRF VPN 1 on this router as well as the VRF customer blue here, and these are the same RTs are being used right now here. So at the moment we do have a VPN between these two routers which is up and running, and if I go ahead and show that to you, I can go ahead and show BGP VPN v4 VPN v4 unicast. Show BGP VPN v4 unicast. Okay, guys, give me VPN v4 unicast. So as you can see here, the command that we ran, show BGP VPN v4 unicast. You can see right now there are two VRFs as we saw. There is a VRF customer blue, there is a VRF VPN 1. Within these two VRF, we do see different routes. So like if you take a look, example VPN 1, we are getting a BGP route 1.1.0.0/24, and this happens to be our local route because if you see the next hop is 000. Hopefully you guys all know the BGP. And now we are getting a route 2.2.0/0/24. As you can see, it is our valid as well as the best path. And if you take a look at both of these symbols, and the next hop for this happens to be 6.1.1.10, which is the loopback IP address of our router 10 in this particular case. And if I go ahead and run the same command on the router 10, we would see similar information. So show BGP VPN v4 unicast, and if I go ahead and press enter here, you would see the same thing on VPN 1. From router 1 611, we are getting a prefix 1.1.0.0/24. So at the moment, between these two sites, we have a VPN v4 configured, and you can see these are the VPN v4 routes that are being exchanged between these two routers. So right now, if you see another thing, I can go ahead and do show BGP VPN, not VPN. So we'll take a look at show BGP VRF VPN 1. So I am right now showing you the routes which are being learned on this router R1 within the VRF VPN 1. So the VPN 1 VRF sees these are the two routes. One, it's its own local route, and one of the route or the prefix or the network it is receiving from router 10. So in this case, the prefix received is 2.2.0.0/24. So right now, what we are trying to do is that anytime if router 1 receives a route from router 10 within VRF VPN 1, we want all those routes, or we want the router 1 to reach router 10 using a SR policy. And we want that SR policy to be created dynamically. Means when the router 1 receives some prefix from router 10. As you can see, we are receiving some prefix 2.2.0.0/24. So the router 1 is right now receiving a prefix from router 10. But we are not doing any action or anything. If you see right now, okay, hey, this is what it sees. We are not making use of any other thing here. And when I say the any other thing, I'm talking about the BGP extended community attribute. So what we want to do, okay, hey, we want to go ahead and anytime when router receives a prefix from router 10, we want router 10 to color those prefix with some color value. You can pick any color value we want. Let's say the color value we want that it is going to use, let's say, we'll say 10 here. So now we are saying anytime when router 10 sends a prefix towards router 1, we want those prefix to be colored with the color value of 10. That means when the route is received on router 1 will receive these routes with an extended BGP community value of 10. Now, once we receive those values as 10, now we can go ahead and configure an ODN template, and we can tell the ODN template look for that extended color value. In that case, that happens to be 10. And if you see 10, go ahead and create an SR policy towards this destination. So let's go ahead and create an ODN policy right now. So let me go ahead and configure. So we go segment routing. Guys, this we are doing on router R1, segment routing traffic engineering. So now we are using the keyword here which is on demand. On demand has an option that says color. So let's go ahead and configure a color, on demand color, and we assume that the color that we will be receiving from router 10 is 10. So we are creating a ODN template based on that color. So we can match that extended community attribute. Now in that, there are few other things that we can go ahead and configure if we need to do that. But right now, that's the minimum thing that we need. Now, what are the other things under this? Now we can go ahead and configure how the path needs to be calculated, other thing. So we are looking at dynamically computed path. So we'll say dynamic, and we want again to make use of our PCE to do the path computation for us. And now we can go ahead and configure a metric type, probably let's say IGP in this case, and I'll go ahead and commit the change. If I come out, now let's take a look at again show segment routing, traffic engineering. So in this case, if you see, we went ahead and configured a ODN template. In this ODN template, we have a source, which is our head end router, which is R1. We do have a color, but if you see, we do not have an endpoint like typically we do have in an SR policy. And that's the difference between an ODN template and again an SR policy. So right now, we went ahead and simply created a template. But is the template up? We can go ahead and verify that. If you guys remember the command, show segment routing traffic engineering policy, and the color value is here 10. So now let's take a look at on this router. We only have one SR policy which is up with color 29, which is our policy 1, but we do not see anything which is related with the color 10, because as I said right now, we went ahead and just simply created or configured a template, an ODN template, but there is no matching. There is nothing is matching against that. That means there is no condition which is on demand, which is requesting this router R1 to go ahead and spawn a policy towards a destination, because for a policy, the another thing that you need is an endpoint, which we do not have right now. So now what is the other thing we want? So right now we know that the router R1 is receiving VPN v4 routes from our router 10 within the verb of VPN 1. So now we will go to our router 10 and we'll say router 10, hey, router 10 will go ahead and start coloring any routes that it's advertising to any of its VPN neighbor. Right now it happens to be our router R1. So now let's go to our router 10. And on router 10, again, if you take a look at, this is what we have. So now we will go ahead and configure. Now for this one, guys, we are using the BGP extended community attribute. Hopefully you guys are all familiar with BGP. So I am making use of the BGP extended community set. So within the extended community set, you have multiple options. So we are using an MLDP opaque type, so which is you will use opaque, and followed by opaque, you can go ahead and give it some number. So in this case, let's say the color, we are calling it color, and the color, that number just for a significance 10. Now what is the opaque value you can go ahead and configure, and you can see there are many things you can configure. So we are configuring an opaque value of 10 over here, and we are just configuring the end set. So what we just did here, guys, we configured an extended community set, and we gave our extended community set a name C10, and within the C10 we are configuring a decimal number of 10, and we are ending our set. So now our extended community set value has been configured. Now let's go ahead and consume that. So how do we consume these things? We consume these things within a route policy. So we'll go ahead and create a route policy. And now let's go ahead and give it a name to our route policy. So we can call it whatever you like. Let's say in this case, I'm going to say set color. And what is the color we are setting? Is 10 in that case. And now within this route policy, we can go ahead and call few things. So we are making use of the keyword set, which sets a route attribute. And in this case, we are interested in setting our extended community, and the extended community in this case we are using the color, which is BGP color extended community, and the color we had just configured using the C10. And now you go ahead and end the policy. So what we just did here, we configured a route policy, we gave our route policy a name, and we went ahead and configured the extended community color over there. Now let's go ahead and commit the change here right now first. And I'm going to go ahead and show you the configuration that we just did right now before we go ahead and proceed further. So if you take a look at here, so here we went ahead and configured a BGP extended community set, and we assigned a name as C10. And within that we are setting a decimal value of 10 here, and we are ending our set. Now to consume this extended community set, we are making use of a route policy, and within the route policy we can go ahead and, so that's what we are doing here. We are saying a route policy, the name of our route policy is set_C_10, and within that route policy we are setting our extended community color, and which happens to be the color value of 10 in this case. Now once that is done, so we have just only configured the extended community sets, but we have not applied these extended community set to anything. So what are we interested? We are saying, okay, hey, anytime when this router 10 within the VRF VPN1, so that means anyone who is a VPN v4 neighbor with router 10 and participating into VRF VPN1. So we want to go ahead and color all the routes in VRF VPN1 with this extended community set, which happens to be C10. So right now if I come back to router R1 again and quickly take a look at in the VPN VRF table. So right now, see, this is what we see in the VRF table, that the VPN1 VRF table says, okay, hey, I am receiving these routes from router 10, but nothing else. It is not receiving any kind of extended attributes as of right now. So now let's go back to our router 10, and now we will go ahead and color all the prefix that we are sending in the VPN1 VRF with the color C10. So now how would we go ahead and do that? So we'll go inside VRF, we call it our VRF name, and now we go inside our address family, VPN v4 address family unicast, and then there are a couple ways. And if one of the thing, if you take a look at, we have the keyword export and import. So now we're going to go ahead and make use of export, because we are going to export. We are saying anything that we are sending, that means we will say export. Anything that router 10 is sending towards any of its neighbor, that means we are exporting those routes. So we are saying export. So with the export, we have an option of specifying a route policy and a route target. In this case, we'll go ahead and use our route policy that we had configured. And the name of the route policy that we had used is set_C_10. So what are we doing? We are saying, okay, hey, that under VRF1, under our address family IPv4, any route that this VRF is sending, exporting, I am applying this particular route policy. And what this route policy is doing, guys, this route policy is setting a BGP extended community attribute color, and we are assigning a color value of a decimal 10. That's what we saw. So now once you go ahead and commit this change, what just happened, that any route, any prefix basically in VPN1 are being exported with this particular route policy. The same configuration under our VRF CBlue. As you can see, VRF CBlue address family, and we are exporting the routes on the, or we are setting the color or BGP extended community attributes onto our VRF CBlue. So now once that is done, now if you take a look at here, this particular router itself, so if I do show BGP again and show BGP, and the VRF name in this case is CBlue. So right now, if you take a look at on this particular router R10, we do not see anything that is being done, because as I mentioned earlier, that particular thing is being applied when the routes are being exported. That means if we need to see if our route policy is getting applied correctly or not, we need to go to router 1. And once we're on router 1, that's the time we can go ahead and take a look at and see what is going on. So now if I come back to our router R1, so let me go back to our router R1 again. Okay, now once again going back to R10, again on the R10, when we do same show BGP VRF CBlue, we do not see anything, as I said, because the config is being applied on the export direction. So now you need to come back to the router R1 and take a look at do the same thing, show BGP, VRF, and our VRF name is CBlue. So right now if you see here the difference on this output, okay, hey, we are getting the same thing. We are getting a prefix 200 from our router 10. But if you see in front of this, we have the C:10. So here the C is really the color extended attribute, or BGP's extended attribute color. And it says, okay, hey, for this attribute color, I see a value of 10. And now because it sees a value of 10, and if you guys recall, we had configured a ODN template. In that ODN template, the only thing we were matching was a color value of 10. And now we do see that the color value of BGP community extended community attribute with the color where we see a value of 10 coming from 61110 for this particular prefix. So if you see in this particular ODN template, and if I read this in the form of an SR policy. So for an SR policy, what do you need? You need a color, which we happens to have right now. You need a headend, which is R1. The only thing was missing was the endpoint. Now, because the BGP, it is on demand, we are getting the endpoint here, which happens to be 61110, because it says, okay, hey, we are getting a color 10 from this particular endpoint. Now, ODN will pick this color value and this destination, and this destination becomes the endpoint. And using these two combination, it will go ahead and create an SR policy. So right now, again, that SR policy will be seen dynamically. So it is not a static configuration. It is only the ODN, the config wise you will see. But if I go ahead and do here, show segment routing traffic engineering policy. Now we would see a policy for the color 10. And as I said, the endpoint in this case happens to be 61110. And we are getting this particular endpoint, guys, from here. Because from this endpoint, we are getting a color value of 10. And as you can see, this is a BGP ODN policy, and right now it is up and up. And this is what are the things that it sees right now here. And that's all kind of pretty much. So this is based on demand. The only thing we had configured was the color. We did not configure any endpoint. Now the endpoint is dynamic based on demand. And if you see, remember, we had another VPN endpoint onto the same router. So if I go ahead and do here, show BGP VRF VPN 1. So right now, if you see for this particular endpoint, we are not doing any color, because if you recall, we had only applied this color to the VRF CBlue, not to the VRF VPN 1. So that's the reason you see none of the routes are being colored for this particular VRF. So guys, that's the whole idea behind the ODN. So again, ODN is on demand. It is primarily used, when you are working with the BGP, and that's the reason when you read some of the documentation, it is also called BGP Automated Steering, or BGP-LS. And what do you do first thing? You will go ahead and configure like your VPN service. Either it could be a layer 2 service or a layer 3 service. And once you have your VPN up and running, you can go ahead and configure this on either side, import side or export side. It's up to you, but majority of the time you will see the documentation is done on the export. So right now on the router R10, we are making use of BGP's extended community set attributes, and we are coloring that particular route. So sometimes this is also called as coloring of slice or slice coloring. So you might see some of these different terminology. Once you have done coloring your particular slice, now ODN will match up, because it will see a prefix coming within BGP extended community attribute. And now we do have an ODN template which is looking for anything that has a color value of 10. And as soon as a match is seen, it will go ahead and create an ODN from, it will go ahead and derive an SR policy. And that's how these policies are on demand. Now if you see right now, we do have a policy because we are coloring that route. And again, if you go ahead and take a look at again the VRF CBlue, now what happens, let's say if this was a trial services as we talked about. Now on router R1, we do not have to go ahead and make any change. Let's say we do not have that customer anymore. So I can go to VRF CBlue, address family IPv4 unicast. And now I can just simply go ahead and say export route policy. and the name of the route policy, and now we go ahead and commit the change, and now that's done. Now if I come back to our router R1 again, and now take a look at the routes that we are receiving. Now that we are still receiving the VPN v4 routes, but we are not receiving any extra BGP community attributes or extended community attributes, and because of that we had an SR policy. Now take a look at what happened to our SR policy. So this particular SR policy just simply went down because it is not, and it will take some time, and we'll clear up this from the database also. So that's what you can see, because we are not matching anything. So this is based on demand. We are not configuring any SR policy manually onto our head end router R1. So that is the beauty, guys. It is on demand. And again, for this on demand to work, certain condition needs to be met, and most of the time it is used in the combination with BGP. And you will see ODN heavily being utilized wherever you are working with any kind of a VPN services. It could be your layer 2 VPN services, layer 3 VPN services, or EVPN as a VPN services. So that's kind of pretty much. So hopefully you guys got some good idea, and that'll be all for this particular lab. I will see you guys in the next episode. Thank you.